Okay, so this time you've really gone deep. Quantum physics and magnets. I mean, you're making my head spin, but don't worry, we're going to untangle this together. We're diving into some really cool research from Columbia University. And there, physicists have figured out a way to use magnetism to solve I'd say one of the biggest problems in quantum technology.
It's a fascinating challenge. Imagine you've got just this amazing spinning top that just keeps going and going. It never falls over. That's what we want for quantum states, that perfect stability. But the slightest disturbance can just kind of knock them off balance, causing them to decohere. And that's a disaster for building quantum devices.
That's like these spinning tops are incredibly sensitive, and the real world is basically one giant earthquake-filled playground for them.
Right.
No wonder it's so hard to make quantum devices that actually work.
Yeah.
But hold on, magnets. How do magnets help with this?
That's where it gets interesting.
They seem like they would just make things more chaotic.
It turns out that magnets can create a sort of invisible shield, a magnetic bottle, if you will, that protects these delicate quantum states from all that outside noise.
Okay, I'm picturing a force field, like something out of Star Wars, protecting those spinning tops from getting knocked over. But how does that even work?
Think of it this way. These magnetic fields, they act as containers, trapping the quantum particles and preventing them from being disturbed by their surroundings. It's like giving each of those spinning tops its own personal bubble of protection.
So we're basically creating a tiny quantum-sized safe room using magnets.
Right.
That's pretty clever. But why is this such a big deal for building actual quantum devices?
Because most of the really exciting quantum effects, they only happen in flat 2D materials.
Okay.
It's like trying to build a computer chip out of a single sheet of paper. But to make real devices, we need things to be three-dimensional.
So this magnetic confinement is how we can finally move those amazing 2D quantum effects into 3D devices that we can actually use. It's like we're taking those flat sheets of paper and somehow folding them into origami computers. But what about the material itself? You mentioned something about a magnetic semiconductor. That sounds pretty high-tech.
That's where chromium sulfide bromide, or CrSBr, comes in. What's special about it is that it's both a semiconductor, which means we can tune its electrical properties, and it's magnetic, meaning we can control how the electrons spin.
Wait, we have control over the spin of the electrons? That's wild.
It's like having two dials to fine-tune the quantum behavior of the material.
Two dials. So what can scientists actually do with these dials?
In their experiments, they were able to change those properties just by applying electric fields and changing the temperature. And here's the really mind-blowing part. They could actually see the magnetic state changing just by measuring the material's resistance.
Hold on. They can see the magnetic state changing. Like literally see it. I thought we were talking about the quantum world here where everything is super tiny.
Not see it with their eyes, of course. But they can measure it. It's like having a built-in indicator light that tells you exactly how the magnetic field is affecting those quantum states.
Whoa, so they can actually see the magnetic state changing.
Yeah.
That's incredible. I never realized you could do that. This CrSBr sounds like it's straight out a sci-fi movie.
It's pretty remarkable stuff, and it gets even weirder. You see, when they were studying this material, they found that tiny imperfections, little defects in the structure, actually made things better.
Wait, what? Defects? You mean like flaws in the material? Wouldn't those mess things up?
You'd think so, right? But in the quantum world, things don't always work the way you'd expect. These defects actually create tiny magnetic fields of their own, acting like extra little traps for the quantum particles.
So those imperfections are actually helping to keep the quantum states stable.
Right.
I'm trying to wrap my head around that. It's like those spinning tops are now on a trampoline. But the bumps in the trampoline actually help keep them upright instead of making them fall over. Who would have thought that flaws could be helpful in this way?
It's a beautiful example of how sometimes a little bit of disorder can actually be beneficial in the quantum world.
Okay, this is already blowing my mind. So we've got quantum particles, magnetic shields, and helpful defects. But where does it all lead? What's the big picture here? Why should you be excited about this, dear listener? Tell me we're not just talking about, like, slightly faster computers.
No, this is so much bigger than slightly faster computers. We're talking about a whole new era of technology. Imagine a world where we can design drugs that target cancer cells at the molecular level with almost no side effects. That's the kind of power we're talking about with quantum computing. And that's just the beginning.
Whoa, hold on a second. We're going to need to unpack all of that. This sounds like it could change everything. But let's take it one step at a time. Tell me more about how this discovery could change the world as we know it.
Let's start with quantum computing. This breakthrough could lead to computers that are millions of times faster than anything we have today, capable of solving problems that are currently impossible, even for the most powerful supercomputers.
Okay, I'm starting to see why you're so excited about this, but let's break it down for our listener. What does a million times faster computer even mean for everyday life?
It means we could revolutionize fields like medicine, material science, and artificial intelligence. We could develop new drugs, design new materials, and create AI systems that are far more sophisticated than anything we can currently imagine.
This is all incredibly fascinating, but it's also a lot to process.
Yeah.
Let's take a breath for a second and then dive into the details of how these advancements could impact you, our listener, in very tangible ways.
All right, so we're back and ready to dive deeper into how this quantum breakthrough could change your world. We've been talking about how scientists are using magnets to protect those super sensitive quantum states, kind of like giving them each a tiny force field.
Exactly. And remember, this means we can finally start building 3D devices that take advantage of those amazing quantum effects we normally only see in flat 2D materials.
Right. It's like we figured out how to fold those flat sheets of quantum wonder into a working gadget. And the secret ingredient is this amazing material, CrSBr. We left off talking about how scientists can actually see the magnetic state of this material changing, which blew my mind, by the way.
It is pretty incredible, and it's all thanks to the fact that CrSBr is both a semiconductor and magnetic. We can literally tune its electronic and magnetic properties, like adjusting two dials to get the perfect quantum behavior. So by tweaking these dials, scientists can control the way electrons spin in the material, which affects its magnetic properties. It's like they're choreographing a tiny quantum dance. But okay, let's get to the good stuff. What can we actually do with this technology? You mentioned quantum computers that could be millions of times faster than what we have today. What does that even look like in the real world?
Well, think about it this way. What takes even the most powerful computers hours, days, or even weeks to calculate today, a quantum computer could do in seconds.
Okay, now you're talking my language.
Yeah.
Speed is something I can get behind. But what are some concrete examples? How could this impact our lives in a tangible way?
Let's start with medicine. Imagine being able to design drugs that are perfectly tailored to your individual DNA, targeting diseases with incredible precision and minimal side effects. That's the kind of revolution quantum computing could bring to healthcare.
Wow. So we're talking about personalized medicine that's not only more effective, but also safer. Sign me up. What else can these super fast computers do?
Think about material science. Imagine creating materials with properties we've only dreamed of. Super strong, incredibly lightweight, able to conduct electricity with zero resistance. These materials could revolutionize industries, from aerospace to energy.
So we could have airplanes that are lighter and more fuel efficient, or power grids that transmit energy without any loss. That sounds like something straight out of a futuristic sci-fi movie.
It does, doesn't it? But it's closer than you might think. And these advancements aren't just limited to the physical world. Quantum computers could also revolutionize artificial intelligence,
Right.
leading to AI systems that can learn and adapt in ways that are currently unimaginable.
I've seen enough sci-fi movies to know that AI can be a bit of a double-edged sword. But if we're talking about AI that can help us solve some of the world's biggest problems, like climate change or poverty, then that's pretty exciting. But before we get too carried away with the future, let's go back to those helpful defects for a second. I'm still trying to wrap my head around how imperfections can actually make a material better for quantum technology.
It is definitely counterintuitive, but those tiny defects are like adding a bit of grit to the system. They create these extra little magnetic fields that help to further stabilize those delicate quantum states.
So it's like those imperfections are actually creating a more robust system,
Yeah.
one that's less likely to be thrown off balance by external noise. I guess sometimes a little bit of chaos can be a good thing, but are there any downsides to these defects?
Well, too many defects could start to interfere with materials, other properties, so it's all about finding the right balance. Think of it like adding spices to a dish. A little bit can enhance the flavor, but too much can ruin it.
That's a great analogy. So scientists are basically trying to find the sweet spot where those defects provide just the right amount of grit, to make the material more stable without compromising its other important qualities. It's like they're quantum chefs carefully tweaking the recipe for the perfect quantum material. But okay, let's move beyond quantum computing for a minute. You mentioned other applications like quantum sensing and spintronics. Tell me more about those. What kind of real-world impact could they have?
Let's start with quantum sensing. These are devices that exploit the extreme sensitivity of quantum states to measure things with incredible precision. Imagine medical scanners that can detect diseases at the earliest stages, or environmental sensors that can track pollution at the molecular level.
Okay, that's pretty impressive. We're talking about a whole new level of detail and accuracy in everything from medical diagnoses to environmental monitoring. But what about spintronics? That one sounds particularly mysterious. What does controlling the spin of electrons have to do with building new technology?
Spintronics is all about harnessing the spin of electrons rather than their charge to process information. It's a radically different approach to electronics, and it could lead to devices that are far faster, more energy efficient, and even capable of processing information at the quantum level.
So we're talking about computers and smartphones that are not just a little bit faster, but potentially thousands of times faster, while also using way less energy. That sounds almost too good to be true.
It is a bit mind-boggling, but the potential is definitely there. And with this breakthrough in using magnetism to control electron spin, the field of spintronics is poised for major advancements. But keep in mind, all of these technologies are still in their early stages of development.
Right. We're still in the quantum kitchen, so to speak, experimenting with different ingredients and recipes.
Yeah.
But the possibilities are clearly vast. This is like being on the cusp of a whole new technological era.
Exactly. It's an exciting time to be alive, to witness the birth of these incredible technologies that have the potential to reshape our world in profound ways.
Okay, so we've explored the mind-blowing potential of quantum computing, sensing, and spintronics. But let's be realistic for a moment. What are some of the challenges that stand in the way of making these technologies a reality? It can't all be smooth sailing from the lab to your living room, right?
You're absolutely right. There are significant hurdles to overcome. One of the biggest is scalability. Right now, these experiments are being done on tiny samples of materials in highly controlled laboratory settings. To build practical devices, we need to figure out how to manufacture these materials on a large scale while maintaining their unique properties.
So it's like we have the blueprint for a fantastic new car, but we need to figure out how to build a factory that can actually produce it efficiently and affordably.
That's a great analogy. Another challenge is integration. These quantum technologies need to work seamlessly with our existing electronics infrastructure, which is based on classical physics. It's like trying to get two completely different species to communicate and cooperate.
So we're talking about bridging the gap between the quantum world and the classical world. That sounds like a pretty tall order. What are some other challenges researchers are grappling with?
Well, there's the ongoing search for even better materials. CrSBr is a fantastic starting point, but scientists are always looking for new materials with even more desirable properties. Imagine materials that can operate at room temperature or maintain their quantum coherence for longer periods.
So the hunt is on for the ultimate quantum material, one that can unlock the full potential of these technologies.
Exactly. And we can't forget the importance of theoretical understanding. While we've made incredible strides in experimental quantum physics, there's still so much we don't fully understand about the fundamental laws that govern this strange and wonderful realm.
So we're building these amazing technologies, but we're still trying to decode the rule book of the quantum universe.
It's a constant process of discovery and refinement. And each new breakthrough brings us closer to a deeper understanding of the universe and our place within it.
This is all incredibly fascinating, but I can't help but wonder, what does it all mean for the future of humanity? This feels like a turning point where technology is about to take a giant leap forward. And I'm not sure if I'm excited or terrified.
I understand your apprehension. It's a powerful technology with enormous potential for both good and bad. It's up to us to ensure that we use it wisely.
That's a sobering thought. But I guess with every great leap forward, there comes a responsibility to navigate the ethical and societal implications. We need to make sure that we're steering this ship towards a future that benefits all of humanity, not just a select few.
Absolutely. It's a conversation we need to have as a society. But I'm optimistic. I believe that by fostering open dialogue, encouraging responsible development, and remembering that technology should serve humanity, not the other way around, we can create a future where these advancements lead to a more prosperous, just, and sustainable world for everyone.
Well said. It's a future worth fighting for, and it all starts with understanding the science, the possibilities, and the potential pitfalls. This deep dive has been a real eye-opener for me, and I hope it's been just as enlightening for you, our listener. But before we get too philosophical, let's bring it back down to earth for a minute. In our final segment, we'll explore some concrete examples of how these quantum advancements could impact your life in the coming years, from the way you work to the way you connect with the world around you. Stay tuned. Welcome back to the final part of our quantum adventure. We've been exploring how scientists are using magnetism to unlock the power of quantum technology, from super fast computers to incredibly sensitive sensors.
Yeah, it's a truly transformative field with the potential to reshape everything from medicine and energy to communication and transportation.
We've covered a lot of ground, but now I kind of want to bring it all home. How could these quantum advancements actually touch your life in the coming years?
Well, think about the devices you use every day. Your smartphone, your computer, your car. All of these could be radically transformed by quantum technology. Imagine a smartphone that's thousands of times faster than your current one, with a battery that lasts for weeks.
Okay, that got my attention. Faster phones and longer battery life. Sign me up. What else is on the horizon?
Imagine a world where self-driving cars are so sophisticated they can navigate even the most complex traffic situations with ease, making roads safer and more efficient. Or healthcare, where you can get a full body scan in seconds, detecting diseases at the earliest possible stages.
Wow, those are some pretty incredible scenarios. But those sound like things that are still pretty far off in the future. What about something a bit closer to home? How could quantum technology impact my life, say in the next 5 years?
Well, you might start seeing quantum-enhanced sensors in your everyday life. Imagine a fitness tracker that can monitor your health with incredible precision, detecting subtle changes in your body that could indicate early signs of illness.
So we're talking about wearables that go way beyond counting steps and measuring heart rate. That's pretty cool. What about the way I work? Could quantum technology change that?
Absolutely. Imagine collaborating with colleagues in virtual reality environments that feel so real. It's like you're actually in the same room together, even if you're thousands of miles apart. Or using AI-powered tools that can automate complex tasks, freeing you up to focus on more creative and strategic work.
So we're talking about a future where work is more collaborative, more efficient, and hopefully a lot less stressful. But let's be honest, not every impact of new technology is positive. Are there any potential downsides or risks we should be aware of?
You're right to be cautious. Like any powerful technology, quantum technology can be misused. There are concerns about data privacy and security, as quantum computers could potentially crack the encryption methods we rely on today.
So it's like giving hackers a new set of tools that could potentially compromise our personal information. That's a bit unsettling. What's being done to address these risks?
Researchers are already developing new encryption methods that are resistant to quantum attacks. It's a constant race between those trying to build more powerful computers and those trying to protect our data.
It's like a high-stakes game of cat and mouse, but with the future of our privacy hanging in the balance. Are there any other potential risks we should be thinking about?
We also need to be mindful of the potential for job displacement. As quantum computers and AI systems become more sophisticated, they could automate many tasks currently performed by humans, leading to economic disruption and social inequality.
So it's not just about the technology itself, but also about how we manage the societal impact.
Exactly. We need to have thoughtful conversations about how to prepare our workforce for the jobs of the future and ensure that the benefits of these advancements are shared equitably across society.
It sounds like we're at a crossroads where we have the potential to create an incredible future with quantum technology, but we need to proceed with both enthusiasm and caution.
I agree. This is a pivotal moment in human history, and it's up to all of us to shape the future we want to see.
Well, I think this deep dive has given our listener a lot to think about, from super fast computers and life-saving sensors to the ethical challenges and potential risks. We've explored the many facets of this rapidly evolving field.
It's been a fascinating journey, and I hope our listener has come away with a sense of wonder and excitement about the possibilities of quantum technology, as well as a healthy dose of skepticism and a commitment to responsible development.
We've only scratched the surface of this incredible field, but I think we can all agree that the future of quantum technology is bright, full of potential, and just a little bit mind-bending. Thanks for joining us on this deep dive. We'll see you next time for another fascinating exploration of the cutting edge of science and technology.